today, wherever you might be in the world, what time it might be. I appreciate you taking, an hour out of your day to come and learn with me. The topic for today is an introduction to the Azure Synapse SQL Serverless Pool. That's a mouthful, but hopefully here in this session and especially through the demos, you'll understand what the big fuss is about the serverless pool, and a little bit about Synapse too. So if you haven't watched any of the sessions that people have done about Synapse in detail, you haven't played with Synapse yourself, then I'll try to touch at least on some of the main fundamental stuff about Synapse too. All right. So allow me to introduce myself. I've been working in the data space and being a DBA or a consultant for the last 15 years. I used to work at Hewlett Packard in Costa Rica. Like John said, I'm a solutions architect at Pythian in Ottawa, Ontario. I'm really honored to be a Microsoft Data Platform MVP. If you want to reach out to me, I am both on Twitter at Warchef, or I would love to connect with all of you. And LinkedIn, just search me by my name and you'll be able to find me. I have a personal blog called createdatapros.com. Feel free to email me there as well as Warner at createdatapros.com. A lot of times people have questions after the fact. Tomorrow you think about something, feel free to shoot me an email, no problem. And if you want to check out the company that I work for, Pythian.com, we also have a big technical blog there that goes beyond the Microsoft stack. Lots of stuff there about open source, Oracle, ML, business in general, etc. Okay, cool. So the agenda for today, I'm going to do a very small Synapse intro, and then we're going to focus on specifically on the piece of Synapse that is the SQL Serverless Pool. And I'm going to try to explain, what this actually is and why we should care about it. And so we'll go a little bit about concepts. There's only about, I don't know, like 7 or 8 slides after this. And then we'll just go through the demos, and then hopefully we'll have some questions at the end, and we'll leave that um, so that there's enough time we can cover everything. And if some people want to see some other stuff about Synapse in the question area, we can, the question section, we can do that as well. Cool. So just in case somebody here has missed the last 2 years of Microsoft marketing, Synapse Analytics is, well, I guess it's not such a new service. It was debuted in November of 2019, but it's still newish in terms of adoption, right? Microsoft is still investing a lot into it, trying to get people to change their mindset from, Azure SQL Data Warehouse to now Synapse Analytics. And the whole point of the service is that it bundles all of the data engineering experience and all of the data analytics platform components in one single workflow in one space. So the Synapse workspace is built on a bunch of different things. The most fundamental one is the data lake storage Gen 2. This is the Azure Data Lake Storage that is underneath the workspace and that you will use in this case as, let's say, your data lake, right? On top of your data lake, then we have both. Actually, I need to update this slide because now there's a third engine, but I'll go into that in a second. Fundamentally, or at the beginning, there were two engines. One is the Spark pools, which are the ones that run Spark clusters. If you're not familiar with Spark, there's a lot of great material online to introduce Spark. I actually have a session where I introduce Spark as well. And the other one is the SQL pools. And the SQL pools are divided in two. One is what Microsoft calls the dedicated SQL pool, which is the database engine that used to be known as Azure SQL Data Warehouse. And then the other one is what is this one that I'm going to focus on today, which is the serverless SQL pool. Okay, and then I'll go into detail in the next slides, of course, into what all that means. And then the rest of the workspace, the really, really important part of the workspace is the data factory slash pipelines. So it's the same engine that runs under Azure Data Factory. It runs the Azure Synapse pipelines. And there's also a strong integration with Power BI because obviously Microsoft owns Power BI. But something very important I always stress to people when they're entering the world of Synapse is that this is just the tool that Microsoft has integrated because Microsoft obviously owns both. But Synapse works just fine with any of the other third-party visualization and analytic tools. If you need to connect a Tableau, a Click, a Looker, any of these modern tools, even if you need to connect more legacy tools like reporting services, for example, or business objects, there are drivers and endpoints that work just like a regular SQL server, and you will be able to do that guaranteed as well. Okay. Now, one final small note is that I did mention that there's actually now a new engine inside Synapse that is not here in this diagram, and it is an engine built for streaming of time series data, and it's called the Azure Data Explorer, and it's in preview right now. But for the purpose of the serverless SQL pool, it has pretty much nothing to do with it. Okay. So SQL pools, digging down a little bit into this, right? So there's two main ways to run SQL. And when I say SQL, I mean basically a modified version of SQL Server. And I'm going to assume everybody that joined this session today has worked with SQL Server, very likely, right? And then most likely you've been programming in T-SQL, for example. So jumping into using Synapse and the SQL pools will be very natural to you. It will be something really easy to adopt and add to your resume. At the end of the day, one of the main reasons why I do all these sessions, a lot of community stuff, is because I'm always trying to help people, learn something new, add it to your resume, something new for the toolbox, go out in the job market. Let's all, get our share of the pie. So SQL pools, dedicated pool and serverless pool. The dedicated pool is an actual cluster of resources, right? So you provision what is called data warehousing units, which under the scenes, all it does is to provision more nodes for your data warehouse. And this cluster, it goes up or down when you start the cluster or when you pause it. And if the cluster is up, even if you're not querying it, you're still paying for those resources, okay? So you pay for the compute that you provision. So every single second that the cluster is up, even if you're not running queries, you're still paying for it. That's the dedicated pool. And you're paying for the storage as well. So the dedicated pool, when you load stuff into the SQL tables inside the dedicated pool, and maybe you're using, let's say, something like column store, when you're loading into those tables that look just like SQL Server tables, and you're loading them and you have column store on them to make them really fast for data warehousing, etc., that storage gets built separate from your compute as well. Okay, but that storage is only manipulated from inside that dedicated pool. Okay, so that's a big difference. The serverless pool, on the other hand, you use the resources only when you run a query. So if you're not running any queries, your serverless pool is going to cost you $0. What you pay for is by the amount of data that you read, and it's approximately $5 per terabyte. And this cost is very kind of like industry standard. If you go into something like Google BigQuery, which also charges per query, it's about the same thing, $5 per terabyte. If you go and you use something like Amazon's Athena, which is very, very similar to the serverless SQL pool, it's about the same thing. It's about $5 per terabyte as well, right? Now, the critical differences here for the serverless pool is that the serverless pool only touches data that is sitting on the data lake storage. At least that is today. Maybe down the line, Microsoft will expand it so that you can query your SQL, that's called your SQL Server tables, with the serverless pool and not just with the dedicated pool, but that is not the case today. Today, when you use the serverless pool, you have to interact with the data lake storage as your underlying storage, okay? So it does not have access to the storage that's in the dedicated pool. Other thing that's about the serverless pool very different from the dedicated one. The dedicated one, I can say, look, I want to go from DW, I don't know, let's make up a number, 1000 that has 4 nodes, and I want to go to DW 2000, so I get 8 nodes. You can do that in the dedicated pool and make your cluster bigger or smaller, right? Right now, again, today, the serverless pool does not have a way to define resource usage. So it's not like you submit a query and you say, hey, give me 4 nodes of the serverless pool to run this query. And you press play, and then it goes out and finds 4 nodes somewhere and then runs the query, and that's it. And you only paid for those seconds for those 4 nodes. That's not how it works. It's actually all automatic right now, which is good and bad, right? It's good that it's all automatic because it's very simple, but it's also bad in a way because If something is indeed slow, you can't throw more resources at it. You're kind of stuck, okay? And that limits, in my opinion, that limits the use case of the serverless pool, right? Because I can't actually control how many resources I want. Other services, I mean, maybe this is the direction that Microsoft will take. I don't know. But other services like BigQuery, for example, in Google's cloud, you can actually specify a compute multiplier. You can say, okay, I know I pay $5 per terabyte read, but this query that's coming next, I'm okay with paying $2 per terabyte read if I can get it, if I can get twice the compute. So that's what BigQuery does. Maybe that's what Microsoft will do. I don't know. But today there is no way to actually do that. So however fast or slow the serverless pool is being for you with your queries, you can try to do optimizations in the storage, maybe compress your files, maybe bring in less columns. You can try to partition your folder structure and stuff like that. But you can't just throw more compute resources at the query. Okay. And because it only accesses data on the data lake storage, right now the serverless pool does not support DML, right? So the only way to write out into the tables, the external tables from the serverless pool, is by replacing stuff, right? So you would take some data that you read from the data lake storage, you would do something with the serverless pool, and then you write it back out into data lake storage. You can't do something like update a table from the serverless pool, or insert into a table from the serverless pool, or delete from a table in a serverless pool. Okay, there's no DML. It's mostly about, you can query the data, but if you need to modify it, you would modify it either by replacing it completely, or with some other way, like let's say like an ETL, or maybe you are integrating Spark with the serverless pool, so you used your Spark to do the modifications, etc., etc. Um, the other thing that it does have is that it does allow you to set some cost control limits. So you can say, don't allow spending more than X amount on the serverless pool because it is charged by the amount of data that is read. You could potentially have, let's say somebody makes a really bad query and just runs it constantly, and then you get like a huge surprise on your bill at the end of the month, right? And that's obviously something that we don't want. So you can set a cost quota on the serverless, okay? And I'll show you that in the portal in a couple of minutes. So there's a paper, you can see a paper online. It's called Polaris, a new data processing engine or something like that Microsoft has published. And I took some of the diagrams from that paper. So these are not my diagrams. These are official diagrams from Microsoft Research. And it might not be exactly this that's implemented under the covers because all that is proprietary and we don't really know. But as far as I understand, speaking to the Microsoft people, it is fairly similar to what is in the paper, right? So we have a bunch of different ways to store data, right? Azure Data Lake Storage, Parquet, and then we have transactional stores. Socrates, I think it's a SQL Hyperscale's code name, Cosmos DB. We already have Cosmos DB enabled, right? There's a functionality called Synapse Link that allows you to read Cosmos DB data from the serverless pool in Synapse. But then the engine, what it does, it takes all these different types of data, creates this abstraction called the data cells, and then it distributes the data cells on a bunch of different nodes, right? Like it says here, distributed data collection, processing, and the data set is a collection of all these data cells created. And as you can see here, so we have this collection of data cells, and then all these different servers, they're the compute servers, they run a cache layer, they have an execution service to coordinate, and they have a SQL Server engine built in to actually crunch the numbers, right? And then they also have a SQL Server front end that's just waiting to receive the queries from the, from outside the service boundary, right? And these are called the centralized services, right? They do metadata, they handle transactions and stuff like that. So each one of these Polaris pool, I assume under the covers, Microsoft has a bunch of these different pools. And when you send something into a particular Synapse workspace, then it just assigns one of these pools to your query. And then once you're done, the pool gets reassigned to somebody else and you're just sharing compute, right? That's how it can be serverless. And it's pretty fast in response time, as in like it doesn't take a lot of time for your query to start processing, right? The query processing might take a while, but it doesn't take a lot of time for your query to start processing. So it's not like Spark, for example. Sometimes if you're familiar, people that are familiar here with Spark, sometimes when you submit something to Spark and the cluster is not up and running already, it takes several minutes. Like if you're working with Databricks or you're working with the Synapse Spark, it takes several minutes just for the Spark cluster to come up and start doing work. That's not the case with the serverless pool. And well, we'll see that in the demo. So some advantages of the distributed architecture, right, is that the service can do auto scale. So if we have all these in this diagram here, let's start with the section on the left that says auto scale. When we see these different nodes, right? Each circle will be a node, and it says, that each node has 4 tasks. The system is smart enough to see, like, well, all these nodes are running kind of hot. Let's create more and distribute the tasks. So it can auto scale. It can also be resilient to failure, right? So if a particular node goes down, this is the center diagram, and we need to redistribute the tasks that that node was doing, the system can do that as well. And as well, if there's a hotspot, so if not all the nodes are super busy, but one of them is getting overloaded, then the system can rebalance some of the work as well, so that it eliminates a hotspot and distributes the workload more evenly on the nodes, right? So these are advantages to having a distributed nature in the engine, as opposed to just like running like one big SQL server behind the scenes, right? And then the last thing to that definitely make it really clear about the serverless pool is that it is really built for exploration, for ad hoc analysis. So like somebody just decides, I really want to see what's in these files. I'm going to explore some of this data. And if you are going to use it for transformations or for reports, you have to do it with things that are not sensitive to latency, because you don't have total control of the resources in the serverless pool. So you never know exactly how long a query might take, right? So let's say I have a report that has to go out at like 6 a.m. and I have all the hours of the night to run it, then maybe the serverless pool is a good way to do it, because I have a big window of time. If the serverless pool for some reason is a little bit slower today, then it's not a big deal. I'm not going to miss my SLA, and it's going to be cheap and easy, because I'm only going to pay for the data that is read, and then it's going to go to sleep automatically, and I don't pay for anything else, right? But if, on the other hand, I'm trying to build a system that's going to be used by hundreds of users, just interactively trying to work with Power BI in direct query mode, then you probably do not want the serverless pool, because it will be um, unexpected how long some of these queries could take, right? And you don't want somebody, like a person, just literally staring at a Power BI that does not refresh, right? So for that, the dedicated pool is still the most robust, the most enterprise ready of the SQL pools, right? The dedicated pool will be the one that I would use if I had to build like, the main data warehouse, the EDW of a big organization. I would not use the serverless pool, right? But if you're doing, pre-aggregations and you have lots of time, or if it's a canned report that, again, you have lots of time to generate, if you just want to explore data, then serverless pool is okay. And that's it. So I'm going to run into demos and then just see the whole thing in action, and hopefully it'll make it way more clear to everybody how it works. So this is the Synapse Analytics Workspace home, in case some of you people might not be familiar with it. I'm just going to do a quick 5-minute intro to the Synapse Analytics Workspace. Synapse has different sections. Data, so it has a Data Explorer. The Data Explorer, you guys will see here from the side, it's divided into a lake database and a SQL database. So the lake database is the stuff that is living in the data lake storage. Usually these are Spark databases. And then the SQL databases are the ones that are either your serverless or your dedicated pool. So you guys see here, I have this demos database that I can use with my serverless pool, and I have this other SQL DW database that can be used with the dedicated pool, right? So I have multiple ones here, and you use the data here for the data panel here just to explore the data that you already have in the service, right? Something important and really cool about Synapse is that Synapse does integrate straight into source control. So you guys can see here, for example, myself, I work quite a bit with this. So I have all sorts of like SQL scripts. I have like a bunch of different notebooks. I have data flows. I have, what else do I have? I have pipelines, right? I have um, here, I have 10 other pipelines. So all this stuff, if I hook it up to my GitHub or my Azure repos, is all source controlled. So I think that's pretty neat. Um, if you do go to develop, you'll see you can save all these other artifacts that are part of the workspace, right? Power Query. So Power Query transformations, kind of like what you would do with Excel or Power BI Desktop. You can save SQL scripts, notebooks, data flows, or Power BI reports as well, right? It has the support, full support for integrating. So developing pipelines, for example. So if I want to say new pipeline, then here I have the authoring space for the pipeline. You'll see all the different activities I can add to my pipeline, right? Same thing as what you would see with Azure Data Factory, for example. And we have a view to monitor what's happening. So we have different pools and whether they're online, whether they're paused, their size, etc. Notice here, right, as I mentioned before, this is the built-in pool, is a serverless pool. And you see here, it's online right now. It's always online unless there's an issue with the service, with Synapse itself. And you see here as well, it says size auto, right? So I don't have a way to say size, 4 nodes, 8 nodes, anything. No, it's simply automatically provided, okay? The difference here, of course, you see the dedicated pool. This is like the SQL Data Warehouse type of clusters. This one's paused right now because I'm not using it. And I don't start it unless I need it because it's going to charge me compute while it's up. But this one I can size, right? You see here it says DW100C. I could bump this up to 200C, 600C, 1000C, and I don't remember what the max is, but you guys get the point, right? You can actually make it bigger or make it smaller, right? And then there's other things you can look at, right? This is the other compute engine that I mentioned, the Spark engine, and this is the new one right here. It said that Data Explorer Pools. That's the new one. That's what it says right here. It's in preview. Okay. And then you can look at some of the other activities that have happened in the Synapse workspace, like the SQL requests, KQL requests. These KQL are the ones that go with the Data Explorer pool, whether you have Apache Spark apps, or whether you did some debug runs of some data flows and stuff like that, okay? And then finally, we have a manage panel where you get all the different things that you can configure in the workspace, such as the different pools, external connections to services that live outside of the workspace. For example, if you want to link a Cosmos DB account, or if you want to use an Azure Purview for data catalog, also the access control. So if you want to provide access to other users to your Synapse workspace, and if you want to add the source control with Git and stuff like that, okay? If I go here to manage and I go to the SQL pools and I go to the built-in pool, you'll see here the configuration here, right? Like I said before, the performance level is always auto, right? So there's no way for me to increase the performance level. It is what it is, at least at this point in time. And I do get different options for different connection strings if I want to generate. Again, remember, it's not just supported by Power BI, it's supported by any tool that can connect to SQL Server, right? Potentially. So ADO.NET, JDBC, ODBC, PHP, right? You can get connection strings for all of those, okay? And the other thing I mentioned on the slides as well is you can do cost control. So if you want to see how much data, you see today I processed 20 megs and I can put daily limits. You can do weekly limits. You can do monthly limits and say how much are you willing to allow to spend on the serverless pool per day, per week, or per month. Okay. All right. So let's go into develop, and I'll go into the script that I have. Hopefully everybody can see well. I did bump it up the zoom here to 125. So there are two main ways to interact with the data through the serverless pool. One is Microsoft has introduced this new version of the OPENROWSET command. If you are familiar with SQL Server, OPENROWSET is actually not new in the serverless pool. SQL Server has had OPENROWSET for a very long time. And the way that it's used is basically kind of similar to the serverless pool. You can use OPENROWSET to go out and connect to something outside of SQL Server and bring data in. In the case of the serverless pool, that something outside is usually the data lake storage that's underneath the Synapse workspace. So that's one way. The other way is to create external tables, and we'll look at that down in the script as well as we go along, right? So first thing, if you go, it's very simple. Just this is why I say that the serverless pool is really optimized for exploration and ad hoc analysis. So if I have a file or a set of files that I am interested in for querying and just looking at the contents, I don't even have to specify a schema, right? You guys can see here, I just do a select top 100 star from OpenRowSet. Then I pass in the path. This is the absolute URL for the file that I want to see. And I just say the format is Parquet and go ahead and run that for me, right? Go ahead and run it. And you see we get the results here. And we get some messages. Usually in the messages, what you will see is the amount of data that got scanned. So you'll see here total size of data scanned is 1 megabyte. Total size of data move is 1 megabyte. Data written was 0 megabytes. And this took 2.75 seconds to execute, okay? There is no way currently to actually dig down into an execution plan or something like that to see if there's space for optimizations or things that we could do better. Again, you could maybe optimize some of the storage based on your own experience, whether, maybe you'll make bigger files, maybe you'll compress them or stuff like that. But there isn't a way to pull out the execution plan and see what it's doing behind the scenes. So that's not there yet. When you run something, you can also come back, do monitor, and you will see the queries that are being run in the serverless pool, right? You see request ID is this one, and this is the query that I just ran, right? But again, you don't get an execution plan, for example, right? All you get is the text of the query. Okay. All right, develop. So that's very easy. And again, you get the results right away. And I didn't have to start fidgeting with creating schemas or trying to figure out what the contents of the file is, right? Because if I just want to see the contents of the file, then it doesn't make sense that I need to figure out what is in the file just to see what is in the file, right? Otherwise, it kind of like doesn't really help with exploration, right? Once you have the Synapse workspace up and running, your primary data lake storage account can actually be referenced from the serverless pool through a relative path. So instead of having to put in, this whole long thing, the absolute URL every single time, if you're just reading a file that is sitting in your data lake storage that's part of your Synapse workspace, you can just use a relative URL like this, a lot simpler. Just say, it's in my data lake storage that's attached to the Synapse workspace, and it's root music data and then this Parquet file, right? And this will work just as well, right? You see here, it works just fine. We can something to check, for example, is you are also able to look at the collation of your database if you wanted to. You can actually alter it if you need to. And then if I wanted to check this again, you guys will see I just changed it, right? I'm just gonna reset it to the default. But something that if you need to do, right? If you need to change the collation for whatever reason, the default one, the case insensitive, accent sensitive one is not good for you. You can change it. You can also remember how I didn't pass in types here, right? I just said, hey, bring me the star, and I didn't specify a schema. You can actually look at what the engine is doing in terms of underlying data types that it's interpreting. So if you see here, I can do described first result set, and I pass in the query that I want to describe the output. And you see here, right, I get the names of the columns that are going to be brought back, and I get their data types. Something interesting to note is that you guys will see here the strings, they are assumed to be varchar 8000s because I believe Parquet has support for the string data type, but does not provide a length. So then if you don't specify anything, the serverless pool will put in the max length for a varchar in SQL, the 8,000 characters to bring it in, right? But if you want to, you can specify other types. So if you see here, for example, I'm doing the same select from that Parquet file, but I'm saying with, give me the artist name, not as a varchar 8000 with the standard collation, but give it to me as a varchar 100 and use this as specific collation when you read this data and you use it, right? So that's something different. And this will work just fine as well. Okay, you can see here, the data is right there. And again, every time that I run one of these, I'm paying for the amount of data that is read. I'm not paying for the compute. And if I'm not running anything, like right now, or just in between queries, then I'm not paying anything at all, right? So that's just a really cool part of the serverless pool, obviously, because if I'm just doing ad hoc analysis or exploration, then I can just run a query, analyze the results, take all the time in the world. And then when I'm ready to run another query, I can do it. And then I'm not paying while I'm analyzing results. I'm just paying when I'm actually running the queries, right? Now I was doing the Parquet example, but it has support for CSV as well. There is two versions of the CSV parser. Microsoft did some improvements. So there's a version 2.0. It's a faster CSV parser. Go ahead and run this. You guys will see. I'll get some data back. I'm not a huge fan of CSVs, by the way. I'm just going to throw that out there for anybody here is starting a new data engineering project. Try to use a file that enforces data types as much as possible. My favorite format, or the go-to for me, is just to get people to use Parquet nowadays, not CSVs, because CSVs is supposedly structured, but a lot of the times it comes mangled up, or people don't quote the strings, and then you get extra commas, or the date formats are not enforced, and all that kind of jazz, right? So anyway, now there is still access to the 1.0 parser, and the main reason is that the 1.0 parser supports gzip still, and that's not implemented in the 2.0 parser. But the downside of the 1.0 parser, other than it's also slower, is that you also have to specify a schema, which again, to me, it kind of defeats the purpose of having a service for exploration of data, right? That you have to tell what the data is just to be able to explore it. But it does work. This is a gzip file that I have in my Azure Data Lake storage. You guys can see it's able to read it. That's okay. And in terms of JSON support, it is really good, mostly because SQL Server itself, right, as most of you know, has implemented really good JSON support after SQL 2016, I believe. So that's about 6 years ago. So that kind of support has been included out into the incorrect syntax. Let me see. That really solid support. There we go. Has been included on the serverless pool as well, right? And you guys can see here. So I have a JSON file that has an element called service users, and that element is an array of objects that have these value types on them: a user ID, a gender, an age, a country, sign up string for that particular user that signed up, let's say to use a service that we're selling, right? So that's just reading the JSON flat, right? I'm just looking at what the JSON looks like. If you want to go digger and really take out the stuff inside the JSON, you can do that through the support again that SQL Server has built in for JSON. If you're not familiar with that, is this open JSON function is really the cornerstone of what you can do, right? So you can do a open JSON for the JSON content. So that's right here. And then you can pick out a particular field, in this case, the service users array, and apply an open JSON on that as well. And I'll show you here what the results start to look like. Usually when you're working with these JSONs that are hierarchical, you end up writing queries that go deeper and deeper into the file, right? And then that's kind of how you deconstruct them, right? So in this case, you guys can see I did an open JSON on the array, and then now I have every single user element as one row, but it's still not normalized, right? We have a column called value that has the full JSON object inside. So now I want to go again one level deeper. All right, so then what we do now another level of open JSON, right? So now I'm going to take the value and then do an open JSON on that, the value. Remember this column is called value. And I'm going to do an open JSON on that. And from that, I'm going to pick out the different fields. So I'll show you guys what it looks like. And we're soon going to get the result that we're all expecting, but not quite yet. I'll show you what it looks like just with this. So you see now what's happened is we do have each specific JSON field as its own row, but it's not exactly what we wanted, right? We want this to be pivoted, right? The user ID to be the column, the gender to be the column, the age to be the column. So we were able to go all the way to this level of depth in the JSON, but it's not exactly the structure that we typically think of in terms of thinking of a normalized table, right? But that's pretty easy to do. Once you are to this level, then you just have to specify the columns that you want. That's what I was missing in my previous query. So once I specify the columns that I want, then I'll just run this. And we get what we actually wanted, right? That tabular structure coming from the JSON file. So pretty good support for JSON built into the serverless pool. Just keep in mind, you got to get familiar with how open JSON works, and you're able to deconstruct pretty much any JSON file that you might get. Something interesting as well, keep in mind, for example, this works very well even if you're dealing with a nested file. For example, I have this Parquet file that has one column that is a string and another column that is JSON. So it's kind of like mixed, right? Because Parquet does not necessarily enforce that it has to be normalized, right? A Parquet file, you can create something like this and just pass in the JSON as one of the fields, right? So we can do the same thing, something very similar, right? Do an open JSON on that Parquet field and specify the columns that we want, right? And then if I go ahead and go to that, I get, again, that tabular structure, even though I'm dealing with Parquet files too, right? And notice something cool about this. If you do specify the columns that you're going to extract, you can even refer to them right in the same query to apply a filter, right? So here I'm filtering the results where the country equals Germany. So I'm able to pass in a filter right away and bring in less records than I have to just to be able to get in my result right away, right? Now, something that people ask me all the time, I have to bring it up because it's important to know, especially if you're going to start a new project and maybe you have a big dependency on XML. Well, if that's what you have, then you probably don't want to rely only on the serverless pool because the XML is not supported in the serverless pool. So I don't know the engineering reason for this, but Microsoft does not support the data types that are built on .NET on Synapse. And so um, we don't have the hierarchy data type. We don't have the XML data type. I I believe we also don't have the spatial data types yet. So for now, there is no support for XML basically. Um, if you're doing a lot of work with XMLs, then I suggest that instead you look at leveraging Spark for that. Okay, so something to keep in mind. Now, how do you create an external table? So an external table, instead of just having to write, OpenRowSet queries to get to stuff, you can create external tables. And the external tables, what they do is they create a fixed schema for a particular type of file or a particular folder. And then you can just use the external table as a regular table and just select from it without, having to worry about anything. I believe I already created this external table. We can look at how you do that. So you give it a name, you give it the schema, and then you have to say where it's located, what's the data source. In this case, it's the data source I created called Synapse. Um, Synapse is the data lake where I'm using with my workspace, and the file format is Parquet, right? Then once you have an external table, you can even create views that use those external tables, and then you can just refer transparently to the view, for example. So you guys see here, I have an external table, then I have a view on top of the external table, and then I just query the view, and it's just transparent. I get the results back. There's no problem. You can also create new external tables. So the serverless engine will write the new table out into the data lake storage for you and create that new table as a serverless table with a create external command. But notice the difference here, right? Create external from existing data. I just put the location here for the existing data. Or I can say create an external table as, and then pass in a select. And when I do that, the serverless pool will compute the select and then write it out into this location with the format that I selected. So if you guys see here, it's music data / full artist profile 2020 November. If I go to my data explorer, show you right now. Here's my primary account. So 1 second. Synapse, music data, full artist profile. So you'll see here what happened, right? I ran these because these take a couple of minutes. I ran them before the session. So we got December and November, for example, right? So I said, well, I want the result of this query to be materialized here in the November folder. And if I go inside there, you'll see created a Parquet file with the data that I wanted, right? And once those are created, same thing, you can just query them any way that you want, okay? And there's a lot of flexibility to query them, right? So if I want to do, for example, select count star from the data that's there in that November, right? It's basically the select count star of this Parquet file. I can go back and do that with OpenRowSet, right? That works really well. You guys see here, I'll get the count, 676 records. And if I want to read the contents of the entire parent folder, this actually will fail if I just put in the folder with the star, because it won't be able to find anything inside the folder, right? And inside the 2020 folder, I don't have data files per se. What I have is more folders, right? So if what you're meaning is that you wanted to kind of like crawl through and give me everything together, then what I do here is I add a couple of stars so that it goes, star for any folder one level in, so November or December, and then another star for pretty much to say any file inside those folders, right? And this I can run, right? Because then that way it'll be instructed to go those 2 levels deep to find the records. And you see here I get the full count, okay? And you can even put wildcards at different levels. So you see here, if I wanted, I only have 1 year, but let's say if I had 2 years and each year had November, then I could put the wildcard, the star, at the year level, right? So I'm doing I'm doing the name of the table, the year, and then the month. If I wanted to see the same month, but for multiple years, let's say I had 2021 here, I could just replace with the star here, right? So that's cool. Gives you flexibility in the wildcard. You see here, right here. That's what I have. I only have one though, but I'll just show you it does work. I didn't have to specify 2020. It's still, understood. Go into any folder at this level, and it still gives me that result. There are some handy functions as well. So if you want to get the file name that is used by the rows, you can run that. See, there's a function here called file name. And here it gives me back the actual file name that it used to compute the result. And if I want to also look at the files, file path, not just the file name, you can get the full file path too. And you can group by the full. See, I can group by the result and then file path 1, file path 2, right? So it gives me file path 1 as year and file path 2 as month. So 2020 December, and I didn't have to specify 2020 or December, right? It parsed it from the storage information, right? So I go here, right? I go 2020, and then I have these two folders. I didn't specify these two folders. All I said is get me the first part of the file path as the year, right? 2020, and give me the year, and give me the second file path as the month, in this case November or December, right? And then give me how many rows there are in each one of those folders, right? And it does that automatically. I didn't have to um, do it myself, right? And then I was even able to use it in the group by, right? If you guys see here, I grouped by the year itself, and I grouped by the month, which was basically the second part of the file path. So it does give you a lot of flexibility as well into being able to really dig into the data lake storage and say, I only want to read for this folder. I only want to read from this other particular folder, or I want to group by a folder in the path, or I want to see what files I'm reading the data from, etc., etc. Okay. All right, so I'm gonna do a recap now, and then we may leave some minutes for some questions before one. Um, so serverless pool, in my opinion, great fit if you want to do low cost exploration, or again, transformation if you are not sensitive to the latency, right? Because there's no way to just pump up the resources. And also, in my opinion, it is not a replacement for a dedicated pool yet because of this same constraint, right? I don't have a way to look at execution plans. I don't have a way to add indexes. I don't have a way to analyze why my serverless pool might be slow, et cetera, et cetera. So again, if you're doing exploration or ad hoc analysis or queries or reports that can take a long time and it's okay, then that's fine. You can save yourself some money. But if it's for full enterprise data warehousing, I don't recommend it yet, okay? Main ways to work with the data is external tables or the OPENROWSET, depending on what you're trying to do. And the reason why I created this session is because I still think that it is very promising to see how this particular service will evolve, because it has a lot of promise. And we have seen how engines, serverless engines like this can be really adopted and work really well. For example, I've had quite a bit of clients working with Google BigQuery, and I think this could be a great initial stepping stone for Microsoft to provide a competitor like that, to be able to just do pay by query, and at the same time give you a lot of functionality as to what it can do, right? The full T-SQL ability of querying, right? And being able to very easily go into the data lake and start exploring files and creating, um, you know, good results for your company without having to boot up a whole Spark cluster and start writing Python, etc. Right? It's just so much easier to jump into the serverless pool if that's what you're trying to do. Okay. All right. So I wonder if we have any questions at this point in time. Um, Let me go check on the. Let me check here. All right. All right, let's see what we have.
We do have, are you waiting for a question?
Yeah, I'm going through the chat to see what we got.
Yeah, there is a question. I already share a link.
Uh,
If you're looking at it, I said that you will provide more details if you want to answer that question.
Yeah, yeah, I see. Yeah, so in the SQL Server, yeah, you can do updates of the statistics if you are working with the serverless pool. Is more of an automatic process. It is not so much as like in the how do you say it, in the dedicated pool world. DBAs are always doing this, right? They are always creating statistics and stuff like that. um, what I found so far is that it's really hard for you to figure out if the statistics are actually working, right? So you can create a statistics, and the system will also automatically create a statistics for you, right? But the problem with the serverless pools, not to say not to do it, right? Not saying not to do it, but the problem with the serverless pool is that is not easy to figure out if the statistics are the problem or not. Okay. So why? Because in SQL Server or in the dedicated SQL pool, when you have an issue and you suspect there's a statistics, what do most people do? They go in, they bring out the execution plan, and then you look at to say what was the estimated count of rows, and then what was the actual, right? And if there's a big discrepancy, then you're like, first thing I want to do, update the statistics, right? So in the dedicated pool or in SQL Server, it's really easy to tell whether the statistics are a problem or not. In the serverless pool, while you can create the stats and you can update them and whatnot, it's kind of hard to figure out if the stats are the issue or not. So what I would recommend is just first of all, leave the system to do automatic um, um, maintenance. There is no setting like to turn it off anyway. And if you do a change, like you're loading some data into the data lake storage that you know is going to affect an external table that you have created, for example, or a file that is used in an important OPENROWSET query, then you probably want to update the stats before you do that. All right. Or sorry, after you do that, after you load more files into your data lake storage. All right. So it says I have, that's one. So hopefully Vasuki, that covers that. The other one says Fazlul says I have my data ingested in ADLS through ADF. Want to perform DML on that data. Can Synapse be used? So DML per se, you will not be able to just run through the serverless, right? You will not be able to just do an insert, an update, or a delete. And if you want to do pure DML with T-SQL, then you would have to load it into the dedicated pool. The other option is to just use Spark, right? And create those that data as Spark tables, which at the end of the day are just Parquet files. And then you can do some DML with Spark, but not all, right? Spark can add data, but Spark can't update or delete data transparently either. You can look into other things like Delta tables, for example, which are part of Spark as well. Ruben said, can we connect Synapse and Databricks? Yeah, you can. You can, I mean, depends on what you're trying, what you mean by connect, right? You can query a Synapse dedicated pool through Databricks, so you can connect to it. Um, you can mount your Synapse data lake storage into Databricks. You can do that as well. You can write from Databricks into your data lake storage and then read that from Synapse. So there's different ways to um, to do that as well. Okay. All right, Murillo Martinez. Oh, I can't see the name. What's the name? Participants. The full name. I don't know. I don't see it. Murillo Martinez. Santiago. Okay. Hey, Santiago. Okay. The conversation. Can I do OpenRowSet data lake query on SQL Server? Um, I don't know. Maybe you can with Polybase these days, because I know Polybase can do a lot of queries that go out into data lake storage, but I haven't tested this, like this exact syntax that we have here on the serverless on SQL Server, to be honest. All right, can Synapse read mainframe data flat files? My guess is that anything that looks like something legacy type of format, I would say when you say Synapse, again, what is Synapse? Most likely, whenever it's something exotic, I tell people most likely you're going to want to do that with Spark, because Spark can do pretty much anything, right? Because Spark, you can run even Java code if you wanted to. So if you find some Java library that can read that format of like legacy mainframe file, which there probably is, then you can run it as a Spark job and you can do it inside Synapse, but using the Spark engine. So that's the thing, right? So always keep in mind, Synapse is like if you want to do enterprise data warehousing, that is really fast, responsive, you do dedicated pool. You want to do ad hoc exploration of your data lake, serverless pool. And you want to do transformations with Python. You want to use all the libraries in the world. You have to develop something that does not exist in the other engines. Spark. Spark, you can do anything. Anything you can do in Spark, right? All right. And I guess I just answered your question there. Fazlul says, when should we use Synapse over SQL? Does it based on data volume? Yes. Well, so it's for analytics, right? So you're not going to use Synapse if you're trying to build a regular SQL server that will be for OLTP, right? So that's number one. If your use case is OLTP, then Synapse is not for it. If you are doing analytics, I would say Synapse is interesting. If you're gonna do data lake, then definitely Synapse, right? Because you're not gonna be able to do it as easily or transparently from SQL Server to use Synapse. But if you're doing a data warehouse, if it's something smaller, you can still do it in Azure SQL and probably will be more cost effective, right? And you can just use column store in Azure SQL and it will still work well, right? But if you're starting to push into the terabyte range, I would say that's when you should look at Synapse. Yeah. So it is based on data volume. And as I said, if you're starting to push into the terabyte range or starting to exceed that, or you think you're going to, then Synapse over SQL is what makes sense to me. Okay. Cool. All right. Well, I think we got everybody's questions. Great. Well, I hope everybody enjoyed the session. It's been my pleasure. And we'll stay in touch, I guess.
That was outstanding.